13.5 is the law of cosines. This is actually going to be a pretty quick one. These here are your three laws of cosines, just like how we had three laws of sines from before. Well, the law of sines was sine A over A equals sine B over B equals sine C over C, so there were three parts to it. This also has three parts. Now, these are all the same thing. All three of these laws are just rearranging what you want to call letter A, letter B, and letter C. There's no reason to memorize all three of them, because understand that they're all accomplishing the same goal. Notice, and this matters every time, whatever letter is being squared out here has the same angle here. So if you have a C squared here, you have a cosine of angle C over here. And the stuff in the middle is always the same. If you have an AB here, you have an AB here. So here we had A's on the outside, so we have B's and C's on the inside. The law of cosines lets us solve triangles the law of sines couldn't. So this triangle here, it doesn't have an angle side pair. We don't know what the side is that corresponds to angle 36. If we knew this was a 12 or something, we would do the law of sines. But since we don't, we have to do the law of cosines. It doesn't really matter what I call these. So I'm going to call this A, B, and C, which makes this side B right now. Well, since I have angle B and side B, those are the ones that that's what I'm trying to find. I'm trying to find side B while working with an angle B, and I'm going to use this version here. Not that it matters, but if you want to think of it that way, you can. So I now know that B squared equals A squared plus C squared minus 2 times A times C times the cosine of B, and B is 36. I'm just going to solve this for B squared. So now I have B squared equals 49 plus 25 minus 70 times the cosine of 36, and I'll just calculate all that now. So B squared equals 17.36. The step you're going to forget, though, the very common thing to forget, is that at this point I still have to square root both sides. I don't care what B squared is, I care what B is. So I take the square root of my previous answer, and I get 4.16. That is now my side B. This is length 4.16. You'll note that from here, I now have an angle side pair. From here on, I could do the law of sines. You only ever have to do the law of cosines once, because once you do the law of cosines, you'll get your angle side pair, and everything else can be done with law of sines. This next one, we're trying to find an angle. I have all three sides, but I don't have an angle. Again, it doesn't really matter what I'm going to call these. I'm going to go A, B, C. Now, I want to find all three angles, but I'll just pick one to start with. Let's just find angle A first. Why not? So I'll call that my theta. Well, if this is angle A, then this is side A, so I know that 8 squared equals, and I'm basically doing this one. Again, they're all the same. It doesn't matter. I'm doing 8 squared equals 6 squared plus 11 squared minus 2 times 6 times 11 times the cosine of A, or cosine of theta, if you want to think of it that way. Well, I'll calculate all this. 64 equals 36 plus 121 minus 12 times 11 is going to be 132, I think. Let me check to make sure that's right. 2 times 6 times 11. Oh, I'm going to break everything. Yeah, well, that's doing its thing. We'll assume that I'm right here. Now, the common mistake is you forget that these are being multiplied. So you cannot try to add that 132 to both sides. Do not try that. It's not going to work because they're being multiplied. You have to solve this with your plain old algebra you've learned before. So first I'll subtract the 36 and I'll subtract the 121. Hopefully my calculator works by now. If it doesn't, I'll pause and I'll try and fix it. Okay, give me one moment. Okay, so I'm going to check 2 times 6 times 11 really quick. That was 132. That was correct. So now my next step was 64 minus 36 minus 121. And that gives me negative 93 equals negative 132 cosine A. Now I'll divide both sides by negative 132. And I get this decimal 0.7045. And now I do an inverse cosine. I'm trying to find an angle. Whenever you find an angle, you do an inverse function. So I'll do an inverse cosine of 0.7045, and that will get me A. So if I do the inverse cosine, I'll have to make sure I'm in radians again. I'm sorry, not in radians, in degrees. So I am in radians. I want to be in degrees. If I do an inverse cosine of my previous answer, I get the angle is 45.2 degrees. .2 degrees. Doesn't look very good, but there it is. Now I would again have an angle side pair. So from here on, I could do the law of sines. So you use law of cosines if you have an angle, angle, angle triangle, or an angle, side, side triangle. In geometry, you were told you can't solve the ass triangles because they're ASS, and that's a pain because they're a pain in the ass. I just said that on a video. But now that we have law of cosines, we can. So the ASS triangles aren't so bad.